Good evening, children. So today we are going to start with alcohol, phenol and ether. So let us begin. So here is the first question on your screen, and the first question is about ether, right? So what happens, children? We'll learn some concepts that when HI is added to ether, what happens? Suppose there's a bigger group and there's a smaller group and you add HI, right? So your I goes to the one which is a smaller group and your OH will be added to the one which has a bigger group, right? So this is the first concept. Okay, then this happens until you have, suppose you are having, okay, so suppose you have, what happens here, you have a group which is bigger group and this is a smaller one, but this can form a stable carbocation. Yes, so when you see that it can form a stable carbocation, a species is available to us, so there you are going to add I, and in the other part you are going to add H, right? So what is the concept? When both are 1 degree or 2 degrees, something like that, the smaller one gets the I and the bigger one gets the OH. But when there is a compound which can form a stable carbocation, the one which can form the stable carbocation gets the I and the other one gets the H. Okay, so that's it. That is the concept behind this here. Okay, so if we see in this question, we are having, this is benzyl and this is phenyl, right? So we know that benzyl can form a stable carbocation. This cannot form a stable carbocation. So the one which can form a stable carbocation gets I. This part is going to get H. So what is going to be A plus B, children? CH2I plus, you are going to get phenol. Yeah, so this is going to be the correct answer. I hope everyone understood this. Let us move on to the next question. So next question on your screen, a mechanism based question. Try everyone. Okay, children. So let us see what's given here. We have been given 3-methyl butane 2-ol. So I'll write down the structure here. To that we are adding HBr. So in HBr we have H plus, Br minus. This H plus can add but there is availability of electrons. It's going to add here, right? We're going to get this as the next step. As you know that this is a very good leaving group, right? So this is going to go. Yes. So when this goes, what are you going to get? You are going to get a carbocation. But as you can see, beside this, there is a group which can form a more stable carbocation. So what do? We do 1,2 hydride shift. right? So basically what we do, we shift this hydrogen to here and we get a positive charge here. Yes, so this is what you got as the new carbocation now. Now you have the negative part here, so you can add Br minus here. So we'll erase rest of the things. Yeah, children. So let us see here what are we going to get. So this, children, is going to be your major product. Do not write Br here. This is going to be wrong. Your Br going to be substituted here, right? Why? Because here we are using the concept of more stable carbocation. Yes, and how we got that? We got that by 1,2 hydride shift. Right? Yes. So this was the concept involved here. So let us move on to the next question. So next question on your screen, I'll be invisible so that you can see the question properly. Okay, children. So let us discuss what is given here. It is given here which one will be the most readily dehydrated under acidic conditions. So which one will undergo dehydration? We know that whenever there is alcohol and your alcohol undergoes dehydration, so it is going to form alkene, right? So all of these when undergo dehydration are going to form alkene, right? And that alkene which is most stable will be formed readily, right? Yes, so we'll check the one which is more stable in case of alkene. We'll try to form in C here. Okay, did you understand the concept? The concept here is that alcohol will get more readily dehydrated whose alkene is going to be most stable. So here we are talking about the stability of alkenes after they are formed. So let us see here. So here we have CH2, here we have CH3. So when this goes and there is H here, so this bond is going to come here and this will go and this bond is going to come here. So what are you going to get in the first case? You're going to get CH3, CH, double bond, CH, C, double bond, CH2, right? This is what you are going to get, children. Yes. So as you can see in this alkene, you have conjugation. What do you have? Conjugation. What is conjugation? Conjugation is alternate, single, and double bonds, right? So here there's a double bond, single bond, double bond. So we can say this is liable for more stability, right? If you see here, Okay, this is a what? Deactivating group. It is not going to activate you. Right, here also NO2 is there, here also NO2 is there. So only one answer is going to be 1. Right? So 1 is going to be your correct answer. Yes. Okay. Okay, so why 1 is going to be the correct answer, children? Because we know that dehydration follows a mechanism where there is formation of carbocation. Yes, and for the stability of carbocation, we need a electron releasing group, but this is a electron withdrawing group. So when the carbocation will be formed, this is going to destabilize. Yes. So everyone understood what's going to happen? Let us move on to the next question. So next question on your screen. Try everyone. Okay, children. So let us continue what is given here. So it's given here, we are having two statements. The acidic strength of monosubstituted nitrophenol is higher than phenol. So phenol is this one. This one is monosubstituted. It can be substituted anywhere, right? Any of the positions it can be substituted. So it is saying that whenever there is a nitro group substituted, that is going to have higher acidity. Yes, this statement is correct, right, children? Because we know that electron withdrawing group aids in acidic strength, right? Why? Because when it is withdrawing the electrons, your OH bond becomes weak. Release of H plus is easier, right? So this one is correct. Can I say the first statement is correct? Yes. O-nitrophenol, M-nitrophenol, P-nitrophenol will have the same acidic strength as they have one nitro group attached to the phenolic ring. So the first statement is definitely correct. Let us look at the second statement. It is talking about the 3 nitrophenols. Yeah, so this is O-nitrophenol. This is M-nitro. This is P-nitro. Right? Okay. These two are very much acidic. But as compared to M-nitro, they are not going to equivalent to any of this. Why? Because we know that NO2 will have both minus R and minus I effect at both ortho and para position, right? So it is very successful in withdrawing the electrons or decreasing the electron density. But talking about at meta position, when we talk about meta position, here there is no minus R effect is not there. Only minus I effect can be experienced. So it is not that effective in withdrawing the electrons, right? So can I say that statement 1 is correct, but statement 2 is wrong? So which one is going to give us the correct one? So your correct answer is going to be option C, right? Yeah, statement 1 is correct, but statement 2 is incorrect, right? Here children, moving on to the next question. So next question on your screen, try everyone. So let us discuss children what is given in this question. It's given here that Lucas test primary, secondary, tertiary alcohols are distinguished on the basis of their reactivity with Lucas reagent. So it is telling that HCl plus ZnCl2 is otherwise known as Lucas reagent. Yes. Is it correct? Yes. And is this used for the distinguishing of 1 to 3 degree alcohols? Yes. This is also correct. Okay. So first statement is correct? Yes. Talking about the second statement, primary alcohols are most reactive, immediately produce turbidity. So this is wrong children, right? Why? Because we know that 3 degree, they produce turbidity immediately. 2 degree, they produce turbidity after 5 minutes. 1 degree, they do not produce any kind of turbidity, right? So as this is producing turbidity immediately, so can I say that this one is the most reactive? So when this is most reactive, the statement becomes wrong and the statement is correct. So can I say that statement 1 is correct, whereas statement 2 is incorrect, right? So that's present in which option children? Statement 1 is correct, statement 2 is incorrect, right? So that's in your option number C. Okay, I hope everyone understood this. Let us move on to the next question children. So next question on your screen. Again, we have discussed this. If you know the formula of anisole, you will be easily able to solve this question. So try. Okay, children. So it's given anisole. This is the formula of anisole, right? So as we know, the smaller group is going to get the I and the bigger group is going to get OH, right? So what is going to be the product, children? So this is going to be our product. And where is this answer written? It's in option number 2. So this is going to be your correct answer. We have already discussed this type of question, right? Okay. So next question on your screen. Let us see what's given here. It is asked the structure of intermediate A in the following reaction. Okay. So what is given to us here? Can anyone name this compound? We know that this group, children, is your isopropyl group. Yes. And this is a benzene. So we call this as isopropyl benzene, which is otherwise known by the name cumene, right? It is known by the name cumene. So can I say if we add O2 here, it will give us so this compound will be named as cumene hydroperoxide, and this is a common method for the preparation of alcohol, as you can see here, right? So where is it present, children? It's present in option B, right? It's present in option B. So option B is going to be your correct answer. Yes. So this is cumene hydroperoxide. This is your correct answer. Yes. Okay, children. Moving on to the next question. So next question here on your screen. Try, everyone. Okay, children. So what is given here in this question? The compound A, if you treat it with Na, it gives you B, right? The same compound, if you treat it with PCl5, it is going to give you C. When you add B plus C, it's going to give you diethyl ether, right? So can I say, children, this is Williamson synthesis reaction, right? Because for this reaction, we need one Rx and RONA. How did I know that this is Williamson synthesis? Because I have PCl5. So one of the product is definitely going to be Cl, right? One of the product is definitely going to be Cl. Yes. So whenever there is going to be Cl, yes. So I'll be having one product as RCl and other product as RONA, right? So as the first product on treatment with sodium gives us B. So B should have Na. So this should be B, right? And when you treat it with PCl5, it's going to give you C. This should have Cl. So this is going to be C. And compound A is what? Going to be the remaining. So we should see that C is RCl, B is RONA. Yes. So B is RONA is not present in any option except in this option, right? So this is going to be your correct answer. This is going to be your correct answer, right? Because I'll discuss again. So this was how you could have done roughly. If you wanted to check whether it's correct or not, you know that we are going to get RCl when we treat PCl5 with alcohol, right? We are going to get RCl when we treat PCl5 with ROH. Then you are going to get RCl, right? Okay. So now let us see. We'll see this whether it comes out to be that way or not. So we have C2H5OH. One side we take it as A and we treat with Na and we give it with PCl5. So we are going to get C2H5ONA. Here we are going to get C2H5Cl. So when we combine this, what are we going to get? C2H5O C2H5. Can I say this is correct? Yes. So when you treat this, you are going to get C2H5Cl, but this is going to be C, but it's given B. That's why this is wrong, right? So when you treat this one, this is correct, but when you treat it with Na, you are not going to get this. Yes, you will get C2H5ONA. That's why this one is your correct answer, children. So which one is going to be your correct answer? Option D is going to be the correct answer. Yes. So next question on your screen. Try, everyone. Okay, children. So here's the next question on your screen. So we are given phenol. And you're treating it with CHCl3 NaOH. Can anyone name in the comment section that what name reaction this is? So as we know that we have CHCl3 plus NaOH. So this NaOH is a base and it's going to take out one proton. So can I say minus H plus? So I'm going to get CCl3. We're going to get CCl3. Then there will be an alpha elimination and you are going to get CCl2, which is nothing but a carbene. So this is your dichlorocarbene, which is your electrophile. Yes? Okay. So which one is going to be your correct answer, children? Your correct answer is going to be option B. Right? Okay. So that's it for today, children. There's many questions. Okay. So more questions are there which are not as relevant. Those were very easy ones. So these were the maximum concept that you could have studied. Okay. So we'll end our chapter with this. Okay. So until next class, take care, children. Bye bye, and I'll see you in the next class.